right. Well, good morning, good afternoon, good evening, everyone, and welcome to today's world's most exciting classroom event with the Darwin 200. My name is Geographic, and I'll be your host for today. Now, as per usual, we have a jam-packed hour-long event for you today. We are going to have a live uplink shortly with the Oosterschelde. We've got the Ocean Conservation Trust joining us from the National Marine Aquarium in Plymouth. We've got an amazing experiment. It is going to be a lot going on. So where is the Oosterschelde right now? Well, last time we caught up with them, they had just left Cape Verde after an amazing week with the Darwin 200 leaders working on conservation projects ranging from sea turtles to lizards to endemic plants. And now the ship is making its way across the Atlantic Ocean. In fact, they just recently crossed the equator. So they are on their way to the coast of Brazil. They are heading across the Atlantic to Fernando de Noronha, and they are going to be there in the next few days. Now, if you haven't visited the site before, you want to take a look at DARWIN200.com, and you will find a beautiful interactive map where you can follow the ship's progress. They share amazing photos and video updates in real time along the way. So you definitely want to spend some time checking that out. If we take a look at our map quickly right now, you can see that we are making our way across the Atlantic. That last little bubble up there with the photos would be Cape Verde. And as they're making their way across, you can see the ship. And then that little blue dot down there, there's Fernando. So you can see that they're getting closer and closer by the day as they're making their way across the Atlantic Ocean. So when we do reach Fernando, we have an amazing array of conservation projects that the Darwin leaders will be working on, ranging from nurse and lemon shark conservation to octopus conservation, coral reef, impact of seabirds and turtles by invasive species, spinner dolphin conservation. So we're going to have a lot of amazing Darwin 200 leaders who will be able to join us in the coming weeks and also share some of the incredible videos that they have created. Now, as I mentioned, the Oosterschelde is connecting with us through the magic of satellite technology. And we have Tom and Rodri and Grant and Ranva who are all hanging out with us right now. So let me bring them in here front and center. There we go. There's Rodri, Grant, Ranva. How you doing? Tom just off to the side. Hey, everyone. It's great to see you. Looks like another beautiful day out on the ocean.
It's pretty clear. It's windy. It's good for sailing.
Excellent. You guys are probably moving along pretty quickly then.
Can you repeat that, please?
I said you guys are probably moving along really quickly, making good time.
We were struggling to hear you because the wind is so good. We're sailing at about 7 knots, so we're actually, if we keep going at this speed, we'll reach Fernando de Noronha about a day early.
Yeah. Ranva, you just joined the ship in Cape Verde. Can you introduce yourself and tell us a little bit about what you do?
Yeah, of course. My name is Ranva Jermensen. I'm from the Faroe Islands. I'm a volunteer for the Darwin 200 project for the leg from Cape Verde to Fernando de Noronha. And whilst we're on this leg, I'm doing a survey for tracking for marine debris. And this is something that you guys can do yourselves at home. There's an app called the Marine Debris Tracker that you can download. And then whenever you go out for a walk, you can take a picture of whatever debris, like plastic bottles or anything like debris you can find, and then upload it so scientists can see it. So we're going to do the same here during the ocean on the crossing. And once we get to Fernando de Noronha, I will also be helping with a coral health project. And here we'll be doing a coral, like we'll do a photo transect, so which means that we'll be taking pictures of like 1 meter squares of corals, so scientists can go in and check how the coral is doing, what the coral cover is, which means how much coral is there per section. And with the coral health as well, we can also monitor the bleaching event. This coral health project will be replicated in every port that the Darwin 200 vessel will get into where there is coral, of course. And you can see that on the map as we go along around the world.
All right. Very, very cool, Ranva. I hate to do this because it looks so beautiful outside, but maybe we can take a little look at the ship and maybe we can head to maybe a more sheltered entranceway or something where we might be able to have a little calmer with the wind. I hate to make you guys move because it looks beautiful.
Absolutely.
Yeah, there we go. The ocean. Let me make that full screen. Beautiful. Audrey, can we look up and see the sails?
Say that again?
Can we look up and see the sails? Can you show us the sails?
Yeah. It looks great. Can you see?
Yeah, beautiful.
Okay, let's head inside now.
All right. Sorry to take you guys out of the beautiful weather, but I think the connectivity, I think the sound will be much better now.
There we go.
Perfect. All right. Well, what I would love to talk about for a little bit is the Sargassum seaweed. You guys sent some great photos and video clips of the seaweed that you were able to collect and some of the amazing creatures you found in it.
Hi, everybody. Yeah, so we were really excited when just a few days ago, I was doing one of my bird watches in the morning, and we started passing by these huge rafts of Sargassum seaweed. And so on board, we had a net that's kind of designed for trawling behind a ship. And so I had the idea of trying to use that net to try to haul up some of the Sargassum and see if we could get any of the like marine zooplankton or fish that lives inside the Sargassum. And it was a really cool project for the day. We were passing through a current. And so that current was bringing a lot of Sargassum from the West Atlantic to the Eastern Atlantic. And for that day, everybody on board got involved with picking through the Sargassum and helping to find out little shrimps and crabs and other. So that you're seeing there, it's a kind of specialized blue copepod. So all the members of this genus are blue, and scientists still don't know why. It could be for camouflage. It could be for UV protection. They don't know, but they're really stunning. I don't think any of this had heard of them before. So here you can see there are two blue copepods mixed in with some of the Sargassum shrimp. This is a species of shrimp that they live their entire lives, just kind of like embedded in the Sargassum seaweed. I should say Sargassum seaweed is characterized by the bubbles that you can see, and so it inflates these bubbles with oxygen, and so the seaweed floats. So you get these floating rafts of seaweed. Here you can see this is a larval fish. We don't yet have an ID on this fish. Larval fish are kind of a challenge, but we believe that it could be in the same family as flying fish or needlefish. But there's actually an expert from the Smithsonian Institute whose specialty is larval fishes, who has been contacted about this one. So we're hoping to get an ID soon. Let's see. And then this is a Sargassum crab. So it's actually the name. This species is another unique species to the Sargassum habitat. They live their entire lives, and they can grow up to about like 1 inch to 1.5 inches across. They're really cool. And then this is a marine gastropod. Also, it seems likely that this is a gastropod that spends a lot of its life in the Sargassum seaweed. You can see it has that kind of like off-brown color, just like the Sargassum. We don't have an ID on this one yet.
Okay, I think this one's my favorite. I love this one.
This one's super cool. So these guys are called sea skaters. They kind of superficially resemble spiders, but they're actually the only known marine family of insects. So they're, you can see, so unlike spiders, they have compound eyes. They have this rich blue color, almost like the copepods, and they also have segmented bodies that are kind of fluorescing in this in the blue. Really, really cool.
All right, very, very cool. So that Sargassum is really like a floating nursery for so many larval creatures, from crabs to fish baby sea turtles, use them for shelter. It's pretty amazing.
That's absolutely right. We were holding out hope to try to find Sargassum fish, which is it's a unique kind of anglerfish that grows up to about like maybe 3 inches or so across. But they're one of the top predators that live in the Sargassum habitat. There's also lots of larger fish that use the Sargassum habitat as well. It's a really important environment.
All right. So we saw some photos. I'm going to play a little video clip I pulled together so we can see them moving a little bit. So here we go. This is a few of them under the microscope so we can get an idea of a little bit of the movement. So we've got that shrimp there.
Can you guys
And so how big of a sample did you guys collect? Was it a fair bit?
So we were scooping through the Sargassum for probably about 10 hours, and just kind of opportunistically, we didn't do the we had to wait for the Sargassum to like drift close enough to the ship and then throw the net at the right time to hope that we could catch some of the bigger mats as they were going by. But I'd say we probably went through, I mean, how much would you guys say? Like, as far as like volume of Sargassum, like,
For sure.
Yeah, in a bread box.
All right, very cool. Well, Tom, I can see we've got you nice and close there. How's it been going with you and Rodri? Are you getting some good footage? Are we going to see some good stuff coming down the line?
Yeah, no, it's been pretty awesome. There hasn't been any big wildlife sightings, but we've seen lots of new birds, which is pretty exciting.
Whales.
Oh yeah, no, we have had whales. Sorry.
Leatherback turtle.
A leatherback turtle.
Sorry.
A magnificent frigate bird.
Yeah, the first frigate birds.
We've been very lucky actually. The last few days we've had a couple of red-footed boobies flying around the boat, and we've managed to get footage of them chasing the flying fish that have been coming up off the ship's bow. So I've seen them chasing the fish and diving in, and every now and then they catch one. It's been lovely to see. We're just going through the footage now, trying to edit a little reel together for it.
Very cool. I'm so jealous of the leatherback sea turtle, largest sea turtle. That's so cool. Very, very cool. Ramba, I know you're sitting just over there, and I know you've been very much looking forward to a crossing of the Atlantic. How has it been?
It's been over all expectations. Really, it's the first time I've actually been on a sailing ship, so it's a very different feeling. So when the sails are up and you're sailing by wind, as opposed to when you're sailing by motor power. So when you sail with motor power, it kind of feels like the ship is really just charging through the waves, and it can feel a little bit brutal. But when the sails are up, it's a completely different feeling. It almost feels like you're going slower, but you're actually going the same speed, but it's much more smooth and a natural.
All right. Very cool, Ramba. I'm so jealous. I bet you can't wait to get into the water once you reach the island.
Right.
Very cool. And then Grant, can you give us an update on the seabird survey? How many species are we at now?
So I believe yesterday we saw our 85th species of bird, and that's since leaving Plymouth, and that was the magnificent frigate bird. We also got really lucky with red-billed tropic birds. They were also using the ship and chasing the flying fish that were getting flushed up.
All right, very cool. Well, let's take a couple questions before we visit the aquarium. So if you're tuning in via YouTube, use the chat to ask some questions. We also have Madame Better's class hanging out with us backstage, some grade 6s. How we doing, grade 6s?
Aww.
Hi.
All right, good to see you. Do we have some questions for our amazing team on the Darwin 200?
Hi. Hi. You know the insect you said that was the only known insect in the water? Is that the one that you always see when you're like canoeing that's jumping on top of the water?
So I believe, thank you so much for your question. I believe that you're probably talking about the water striders, which are a different group of insects than the sea skaters. So the sea skaters What's special about those is not only that they live exclusively on the water, it's that they live exclusively at sea and in salt water. And so they're the only insect that lives in the ocean. Thank you so much for your question.
Very cool. Do we have another question? Oh, yeah, lots of questions. Okay, come on up, whoever's next. Oh, no, you're just waving? Okay, that's okay too. All right, we'll come back to you for a question during the aquarium time. All right. Well, before we sign off with you guys for today, about how long do we have sailing before you're expecting to reach Fernando?
The original ETA was that we arrived on Sunday. I don't know how that's looking now.
Well, it all depends on the wind. If the wind is with us, we might get there on Saturday early, but if it slows down, it might be a bit later. So we're a bit at the mercy of the wind and its powers.
All right, fair enough. Well, it has been great to make this connection. I know the weather didn't quite cooperate with us last week, so it's good to see your faces and to know that you're seeing lots of cool things. Maybe if it's not too much of a hassle, can we get one more ocean view before we wrap up today?
We can do that.
Excellent. Excellent.
Which, is this the right way up or the other way?
The other way.
Does it matter? Okay. All right. We'll go through the emergency hatch.
Perfect. The connection
direct to the access.
today. The satellite connection is amazing. Oh, as I say that, we lost them for a second. But hopefully they'll pop back in for another moment and we can get that view. I think either the connection went down or maybe one of them accidentally touched the button. Oh, there they are.
Okay. Sorry about that. I think I hit the wrong button.
That's okay. No big deal.
All right. Let's see. So if I tap this. All right. Let's see. So we're up on deck now. There's the sails and there's our water. If you look carefully, you might see a flying fish. Oh, I see some.
Beautiful.
Do you see the flying fish?
I think they might be a little too small for us, but
they're all over the place. I wish we could share. We'll have to get some good pictures.
Keep an eye out for some pictures and some video.
Absolutely.
All right. Well, thanks so much, guys. Enjoy the next few days, and we'll see you when you arrive in Fernando de Noronha.
Goodbye, everybody.
Thanks, guys. Okay, we are going to head now to Plymouth in the UK, where we are going to join up with the Ocean Conservation Trust at the National Marine Aquarium. Now, you may remember that a couple weeks ago, they had an amazing experiment for us where we had a whole group of undersea creatures join us and blow into some water and show how the carbon dioxide changes the pH levels. So cool. So now we're going to join with them and we're going to talk a little bit about what happened in that experiment and learn a little bit more. So let's bring them in live with us right now. Good morning for me. Good afternoon for you. How are you doing today?
Hello guys, thank you Joe. So my name is Georgia and I'm here at the National Marine Aquarium in Plymouth. And as Joe mentioned a couple of weeks ago, my friend Becky, she showed you the pH scale. So this tells you if something is an acid, like vinegar or lemon juice, if it is neutral, like pure water, or if it's an alkali, like toothpaste. And then she showed you a little experiment where some animals, they had a beaker like this, or a measuring cylinder like this with water and universal indicator in, and it changed the colour of the water depending on the pH. So here we have got neutral water because it's green, showing that it has a pH of 7. But when you blow through a straw into the water, it changes the colour. Because as you exhale, when you breathe out, carbon dioxide from your lungs dissolves in the water, turning it more of an orangey yellow colour. And this shows that we've turned the water more acidic. And this is exactly what's happening in our oceans today. So what we're going to look at this afternoon for us is we are going to have a look at exactly what happens to the carbon dioxide when it dissolves into the ocean. So we're going to move over to this board, and we're going to be doing some quite serious ocean chemistry. Now, it's worth mentioning the stuff we're going to talk about is very high level stuff. It's the kind of topic that university level researchers are looking at the minute, but we're going to make sure that it's nice and simple so that everyone can understand. So on the board here, I've got a diagram, and at the top we've got the atmosphere. The atmosphere is like the blanket of gases around the Earth. And one of the gases in the atmosphere is called carbon dioxide. Now, carbon dioxide is made up of one carbon atom, so we've shown this with the letter C, and it's bonded to two oxygen atoms, and we've shown those with the letter O. Now, carbon dioxide exists naturally in our atmosphere, but because of human activities like driving cars or generating electricity to power our homes, we're producing lots more carbon dioxide. And it can't all stay in the atmosphere. Some of it will dissolve into the ocean. When it does that, it binds with the water. So does anyone know what the chemical formula for water is? If you do, you can call it out. And if you said that it's H2O, you're exactly correct. So water is made of one oxygen atom bonded to two hydrogen atoms. So in our ocean, we've got lots of water. And as I said, the carbon dioxide from our atmosphere can dissolve into the ocean. And when it does this, it reacts with the water to form something called carbonic acid. Now, this carbonic acid, it doesn't hang around for long because it goes through a series of chemical reactions, and what happens is the hydrogen atoms, they actually separate, and they become something called hydrogen ions. So hydrogen ions, they exist in the water, and we're left behind with a new substance. It's called a carbonate ion. Okay, so you don't need to worry for now what the word ion means. You just need to know that when carbon dioxide dissolves in the ocean, it firstly forms carbonic acid, and that then splits into a carbonate ion and some hydrogen ions. Now, these hydrogen ions, they're going to cause us a bit of a problem in a minute, but we're going to forget about them for now, and we're going to focus on our carbonate ions. Carbonate ions are super important for lots of marine animals, as I'm about to show you. So over here on this table, we have a selection of some wonderful marine artifacts. These are all real, and they've come from real marine animals. And all of the animals on this table, they have got shells. And these shells are made of something really important called calcium carbonate. So all of these animals, they take calcium out of their environment. They react that with the carbonate ions. So that's what we just mentioned on the board a minute ago. And they then form calcium carbonate. And that's what all of their shells are made of. So in this first section here, we've got lots of shells from animals that are mollusks. So we've got clams, we have got a nautilus shell here, and a nautilus is very closely related to animals like squid, octopus, and cuttlefish. Now, these are all called mollusks, and other mollusks include marine snails. So these shells have come from these marine snails. And whilst an octopus and a marine snail seem very different, they're actually part of the same mollusk group. And a little bit later in the show, you're going to see a cool experiment about snails. If we move along slightly, we've also got in this middle section here some crustaceans. So we've got a European lobster and a crab. This is an edible crab. Now, these are not the animals themselves, they're just their molts. So this is where Lobsters and crabs, they grow in size, but they can't stretch their shell. So what they have to do is they shed their shell, a little bit like a snake shedding its skin, and what's left behind is the molt. It's just kind of the outside shell of the animal. And then the animal can grow a new shell made of that calcium carbonate. Now, lastly, we have some corals. Corals are a completely different group of cnidarians. And the animals that live inside a coral, they are protected by this calcium carbonate skeleton. So just like all of the animals on this table, they have this shell for protection to help them survive and to keep away any predators. So we can see that carbonate ions are so important for all of these animals to make their shells to enable them to survive. So, with that in mind, I would like to introduce you to a very good friend of mine. Here we have got my wonderful friend, Ian, and Ian is an edible crab. Now, Ian, could you please turn around and show our audience your fantastic shell? Now, remember, Ian's shell is made of calcium carbonate. So he needs those carbonate ions from the ocean to make his shell for protection. Now, Ian, you can face back towards our audience, wonderful. And I'm just going to go back to our diagram again. So here, we've got our ocean, and remember our ocean is filled with those carbonate ions and those pesky hydrogen ions I said that were going to cause us a little bit of bother. So, for Ian to keep his shell nice and strong, sturdy for protection, he needs to get as many of those carbonate ions as possible. However, there's some hydrogen ions around, and they also want the carbonate ions. There's a bit of competition going on. So, in a minute, Ian, you are going to do your best to try and get as many carbonate ions as possible to help you build your shell. But you need to be on the lookout for those hydrogen ions. They're going to come in and try and grab them. I'm going to count you down, and you can go in 3, 2, and 1. Oh no, so the hydrogen ions have come in, and they are starting to take away those carbonate ions. And remember, that's what our friend Ian needs to make his shell. So Ian, you have not been able to get the carbonate ions. And that means you're going to have to spend a lot more energy trying to find them. This then means that Ian's going to have less energy available to try and catch food, meaning you're going to be quite hungry. And also, because you've not eaten as much food, you're going to grow smaller in size. Now, this can have a long-term impact on the food chain. So a food chain is where you have different animals eating each other all the way up to a top predator. And they all really heavily depend on each other. So if Ian's body size has grown much smaller, the animals that would eat crabs, like Ian, they're going to have to find a lot more food to be able to continue having enough energy to survive, which is going to pose quite a big issue for them. Now, if this continues, if we keep putting lots more carbon dioxide in the atmosphere, it continues to dissolve in the ocean, producing those hydrogen ions, our ocean is going to get much more acidic, which can eventually cause animals like Ian to start to dissolve. Their shells will start to dissolve, which is going to, unfortunately, be the end. So, Ian, thank you so much. You've really helped us to understand what happens to carbon dioxide when it dissolves in the ocean. So, we are just going to end this section having a little think about some positive things that we can do to help our friends like Ian and other animals and habitats in the ocean. So a couple of weeks ago, when you saw my friend Becky, she asked you to have us think about some things you can do to reduce how much carbon dioxide you are responsible for emitting. Now, You entered some of your ideas online, and these were fantastic to read. If you didn't have a chance to think of any, that's not to worry. We're going to talk about some now. So these are all things that you can do to reduce what's called your carbon footprint. One thing you could do is just reducing how much you drive. Now, I doubt many of you have driving licenses yet, but I'm sure we're all responsible for sometimes asking our parents or our grown-ups at home to give us lifts to places that we could probably walk, cycle to, or even get the bus. Other things that we could do is making sure that we switch off any electrical appliances that we're not using. For example, leaving the lights on, leaving the telly on, leaving your PlayStation or Xbox on. If we're not using them, then it's a really easy thing to do. It's just to switch it off on the wall so that it's not wasting any energy. Something else we can do is try to eat less meat. So meat is a really big contributor of carbon dioxide. Now, we're not saying that you don't ever need to eat any meat, but just by reducing how much you eat, it can have a really big impact on carbon dioxide emissions. And one last thing that we can do is just being really responsible about the things that we buy. So reducing, recycling, or reusing things, especially plastic, can have a big impact on how much carbon dioxide is released into the atmosphere, which in turn will help our animal friends like Ian the crab. If you are stuck for ideas on what you could do, here at the Ocean Conservation Trust, we have something on our website that can help you. It's called our Think Ocean Challenge. So if you go online and search for Ocean Conservation Trust, Think Ocean Challenge, you can take our quiz and it can tell you what kind of shoal you belong to. Then it will give you a list of some ideas, some easy things you can do to reduce your carbon footprint and also help the ocean. So that's all from us here at the Ocean Conservation Trust today. I'm going to pass that over to Joe, and he's got some announcements to make from some winners that won a competition, giving their ideas of how they can reduce their carbon footprint.
All right, Georgia, thank you so much for that great presentation. You made it nice and simple to understand, very visual. And poor Ian the crab, he just didn't stand a chance against those hydrogen ions. All right. We want to announce our winners from 2 weeks ago when we did the experiment together. So I'm going to share my screen here really quickly and we'll make the announcement here of our winners. Oops, I lost it there. Let me open that one more time. Okay, here it is. So taking a look at our winners, we want to start off with Sophia. Sophia, age 7, is our first winner here. So Sophia said that the pH was originally green and then it turned yellow. And then to reduce carbon, we could plant trees and flowers. And she did some wonderful decorating here. So congratulations to Sophia, age 7. That was a great picture that you did there. Then we have in second place from London, we've got, there we go, Bo in London. So said the experiment turned orange and to eliminate carbon dioxide, gave some great examples here, like not driving as much, planting more trees, not burning coal, using renewable energy. And then Sam from Vancouver, age 13, was our third place winner. So keep an eye out for your £50 gift cards from Amazon. And thank you so much for submitting those great answers to the experiment. We have a new experiment that we're going to showcase in just a moment. But before we do that, we're going to play a little Kahoot together. So Georgia, I'm going to tuck you away temporarily and we're going to play a little Kahoot action. Thank you so much. So if you are at home, if you are in the classroom, you can get in on the Kahoot right now with us. Let me load up the Kahoot screen here. And just a reminder that there is, for the first place finisher, a £50 gift card for your classroom. So we should see it loading up here. You want to go to kahoot.it, kahoot.it. And then our PIN number for today is 898635. Now, if you have one-to-one technology like a Chromebook or a tablet, you can jump on like that. If you're at home and have a tablet or a phone, you can scan that QR code. If you don't have one-to-one technology, your teacher could pop this up at the front of the room. You could shout out your answers to him or her. If you can't connect, no big deal. You can still play along. You can still see how well you do in the Kahoot for today. So we'll just give a moment here as classrooms, as students are loading up. There are going to be 4 questions, 20 seconds for each. As per usual, a little multiple choice, a little true and false. And then the questions are just based on what we were just talking about with the Ocean Conservation Trust, and then a little bit about with our crew, with Rodri and Tom and Ranva and Grant on the Darwin 200 out on the Oosterschelde. Okay, let us get ready to get started here. I'm going to turn up the volume a little bit so we can hear a little bit of that fun Kahoot music. And let's see who comes out on top today. Counting us in, we've got a 3-second countdown. Here we go. So, first question. The largest sea turtle is it the green sea turtle, the leatherback sea turtle, the olive ridley sea turtle, or is it the hawksbill sea turtle? So 4 choices there. They just saw one on board the Oosterschelde. They can be over 1,000 pounds, which is absolutely amazing. What a massive sea turtle. It is the leatherback sea turtle. Good job, crew. That puts the Radiant Finch in first place. We're going to go to our next quiz question. If something has a pH of 4, so less than 7, it is acidic, basic, or neutral. If something has a pH of 4, it is acidic, basic, or neutral. Got a few more seconds to get your answer in. We've got some delicious orange juice there to give you a little bit of a hint. All right, good job. Acidic is the correct answer. That puts the groovy otter into first place. We've got a true and false question coming up. Marine snails are mollusks, just like squid and octopus. Is that true or is that false? Marine snails are mollusks, like squid and octopus. We're going to talk a little bit about snails shortly. It's going to be the focus of our experiment today. And we also have a special guest who filmed a great video for us on giant land snails. All right, absolutely true. They are mollusks, just like our squid and octopuses. The fast pigeon has snatched that top spot. We have one more question. Calcium carbonate makes up the shells and the hard parts of crabs, coral, marine snails, or all of the above. Don't let that picture fool you. Is it crabs, coral, marine snails, or all of the above? Calcium carbonate makes up the shells and the hard parts. All right, it is all of the above. I can see that having that crab picture had a few quick ones choose the crab, but all of the above is the correct answer. Let's see what that did to our podium. In third place, we have the mystery dragon. In second place, we've got the fast pelican. In first place, holding down that top spot, and our winner for this week, the genius boa, coming in right at the very end. So the genius boa, good job. I'm going to share an email address here, ebtsoyp@gmail.com. If you are the genius boa, you need to send me an email message and we will make sure we send along that Amazon gift card. So thanks to everybody for playing along today. And a huge shout out to the Ocean Conservation Trust for such an amazing presentation. They made everything so easy to understand. Thank you so much for being with us today. Now, as I do mention, we do have a new experiment coming up, and it is focused on snails. And I think it'll be something that'll be really fun for classrooms to give a try. And then, of course, send in some answers to the questions for us. Now, I am going to play a little presentation first from Martina Panisi. Now, Martina spends time on Sao Tome and Principe, 2 tiny little islands off the coast of Africa. She's a conservationist, and she is looking at species there, in particular the obo snails, these giant snails, which are endangered due to things like habitat loss and invasive species. And so she's going to talk a little bit about the snails and about what they're doing to try and protect the snails. And then we'll take a look at this week's experiment. So here we go. let me cue up that video and let's take a little look with Martina.
I want to take you with me in a small journey to the place where I fell in love some years ago, and I'm still working as a conservation biologist there. So to tell the story of the giants, we have to go in the Gulf of Guinea on the equator line in Central Africa. And there we can find two small islands that form the Republic of Sao Tome and Principe, which is the second smallest African country. And these islands are volcanic islands. And when they originated, it started to be they were always separated from the continent during millions of years. And the species that eventually got there, they were separated from the other species on the continent. So they started to become unique. And that is why there is a high number of unique species that only exist there. And this is these islands are part of one of the biodiversity hotspots worldwide. A few of you know that land snails and slugs are one of the animal groups that were most threatened in the last decades by human activities, mostly because even if they are very slow, and if something is impacting their habitat, they can't really escape very in a high speed. But this is just one reason. Anyway, if we can just imagine the Hawaii wonderful islands where there are hundreds of species of land snails that only exist there, and just a human introduction of one carnivorous species led to the decline of dozens and dozens of species. There is always somebody that needs to get interested about its story, otherwise it can disappear from the environment and nobody will ever understand it disappear because nobody even knew about their existence. So here we are for the first time. One of our first survey tried to understand if the species was still there, if it was declining, and why. And it was actually very difficult because here we actually got stuck in the forest because eventually the river got very full and we couldn't cross. But during months we started to search for the species. And it was a difficult task because all what we could find was just this other species, which is an invasive species of also giant snails that was introduced at the end of the 80s from West Africa. And as people eat it a lot widely, they also introduced it all around the islands. So we only could find the introduced species, but there was no sign of this other of the bull giant snail that only exists on these islands. So we asked for help, and we asked to hunters and local guides to take us in the places where this species still existed. And we were also actually losing hope because everybody was like, yeah, it's very far in the mountains, but we don't really know where it's there. But then we would go there and it wasn't there. And finally, we find it. And it was a very emotional moment because imagine that you are trying to study a species during months just from historical records, and you finally have it in front of you, and it probably has never seen a human, and you are there, and you are acknowledging its existence. And however, even if it's joy at first, we were also very disappointed because we knew that all these efforts were ending in finding just some dozens of individuals of this species. So the species was declining very rapidly, and the causes of its decline was the destruction of and a modification of the forest, the introduction of these other small species I showed you before, and also people were harvesting this species. So at first we were kind of sad because we didn't know what to do now. Okay, we have some scientific data, but we should do something. We should act to do something. The first things we did was to join people from different generations and try to create open debates. And this was a good strategy because elders and adults could see that the young generation didn't even know about the existence of the unique species that exist in the forest, and they only knew about the introduction, about the invasive species. So they also suggested to start doing some actions such as building a small center where we could study the species. We didn't know anything about its ecology, its reproduction. Was it possible to reproduce it in captivity? If it was disappearing so fast in the forest, can we help it outside of the forest as well? And also as a mean to aware other people, and mostly young generation, about the urgent need to protect the species. As we first thought there were around 40 species of land snails and slugs on these two islands, we finally understood that there are 86 species of land snails and slugs, and 55 only exist in Sao Tome and Principe. So they are endemic to the islands. And we also take advantage of, while we were studying and protecting the species, to show them to the young generation and make them understand that we are never too small to make a difference, that they have a big role to protect the forest. Even if they are still young, they are very important for the future of the forest, from the smallest to the biggest animals and plants that live there.
All right. So a huge shout out to Martina and sharing that story with us. And it really ties in nicely with a theme that's come up repeatedly on the World's Most Exciting Classroom, and that is islands. How islands are isolated. You get endemic species found nowhere else on the planet. We learned about some in Tenerife. We learned about some in Cape Verde. And I have no doubt that when the team arrives on Fernando de Noronha, that they will find some endemic species as well. But being endemic and in a small spot means you're susceptible to changes like habitat loss and pressure from humans, invasive species being brought to those islands. So that is what's happening with the obo, those giant snails. But it's great to hear that there's some real great conservation work going on as well to protect them. So that brings us to today's experiment. Let's take a little look at the experiment that you can do, you can replicate, and then you can get your answers in for a chance at one of the 3 $50 gift cards.
If there's something you can be sure about, no matter what country in the world you live in, it's very likely that you probably have a snail nearby, perhaps in a garden or in a park or in a woodland near to you. But have you ever looked at a snail up close and personal and seen the incredible intricacy of its body and movements? Snails belong to an ancient and really diverse group of animals called the mollusks. These are invertebrates, so animals without a backbone, and they stretch back millions of years, which is partly why they're so diverse and plentiful. Mollusks include, of course, land snails and their close relatives, marine snails, but they also include bivalves, such as clams, and even cephalopods, octopus, squid, cuttlefish, and their relatives. Those are all related to our humble little snail here. There's a really amazing activity you can do at home or in your school to study a snail up close and personal. You need a sheet of glass. This could be a picture frame. Obviously handle it very, very carefully and have adult supervision because glass can be extremely sharp. If you can't get your hands on a sheet of glass, you can even use a glass jam jar or even just a glass cup. But generally, a flat sheet of glass works much better. If possible, get yourself a magnifying glass so you can really see your snail up close and personal. Land snails generally live in moist habitats, so it's important that they don't dry out. Your first step is to spray your sheet of glass with water. You could use a plant mister if you've got one, or if not, you can use a wet towel or a wet piece of cloth. But make sure that your sheet of glass is covered with a film of water. This will keep your snail happy. The next step is to go into your garden or park or local woodland and find a snail. Be very, very careful. Pick him up very, very gently and don't grab him by the shell. If you pull the shell, it'll hurt his body. So gently, gently pick him up and then bring him back to your sheet of glass and just place him at the bottom. He'll naturally try and climb up your glass and try and climb across it like this little guy here is doing. This is a particularly adventurous snail. You're now ready to study your snail in detail. Look through the magnifying glass and just watch the snail for a few minutes. See how he moves and how he behaves on the glass. If you look really carefully, you'll see that he has 4 tentacles with light-sensing organs that act like eyes. Snails have a completely different visual system to humans, but nevertheless, this little guy here can clearly see what's going on around him. He's having a good look around for new areas to explore, I think. Have you ever wondered how a snail moves? Obviously, snails don't have feet like humans and other large animals. But yet, snails can not only move along flat surfaces, they can climb up a vertical sheet of glass, just like this little guy's doing here. When you stop and think about it, that's pretty amazing. Very carefully, put your snail on your sheet of glass and then go to the other side and watch through the glass to see the bottom of his foot. The foot is this organ at the very bottom of the snail's body, and this is how he propels himself along. The snail should naturally try and climb up the glass, and if you look very carefully, you'll see this rhythmic movement as the muscles of his foot propel the snail forward. This is how he grips onto even smooth surfaces and slowly propels himself along. Now for this week's activities. If you go to the DARWIN200 website, you can download an instruction PDF to answer 3 questions within the next 2 weeks to win 3 Amazon voucher prizes. My 3 questions for you. When studying your snail, try and look at his mouth. How do you think a snail feeds? Does he have teeth? Does he have a mouth like a human or a mammal or a reptile? How is it that this incredible little animal can eat leaves? And how does his mouth work? Your second task is to find a snail and identify it. Find out its common name in English and also its Latin name. This little species is very common here in Europe. What species do you think it is? My third and final question for this week's activity is, why does a snail make slime? Can you work out why a snail needs slime and what advantages and disadvantages it may pose? As usual, please send in your answers by either uploading them via the DARWIN200 website or email them to classroom@darwin200.com. Join us in 2 weeks and we'll go through the answers. Good luck and enjoy studying your snails.
All right, so another great experiment from Stuart McPherson, our expedition leader. As he said, you have 2 weeks to answer those questions and send your answers into classroom@darwin200.com, and we will select 3 winners for the $50 gift cards. You have 1 more week to submit your answers for last week's experiment, which was the pitfall traps. So if you haven't taken a look at that, you should head over to the website, darwin200.com. And you can watch the video. You can find the PDF, which has the information and the questions that you need to answer, and how you can send in those answers to us. The pitfall trap looks like a lot of fun. We're really looking forward to seeing hopefully some pictures from students who have tried the pitfall trap. Hopefully we see some pictures from students who try the snail experiment to see how the snail moves along the glass. You can post those pictures online, #Darwin200, tag @Darwin200 on social media, so we can take a look at some of those pictures from those experiments. So 2 weeks for the snail experiment and those questions. Now we're going to wrap up today with the curiosity of the week. So let's find out what last week's curiosity was. We'll see if any students got close, and then we'll wrap up with this week's curiosity of the week. So here we go. Let's take a look at what last week's curiosity was.
I asked you to try and guess what these strange masks might be and what their purpose is. Well, the answer is that they're fire dancer masks. Believe it or not, the incredible Baining people of New Britain off the coast of Papua New Guinea wear huge masks bigger than these, and they leap through fires. It's an ancient spiritual ceremony, and there's multiple types of masks. Many of them represent spirits from the forest. So if you guessed fire dancer masks, you are correct. Well done to those that guessed correctly, and you can try your luck on this week's Curiosity of the Week.
Okay, so we did have some great guesses that came in for last week's Curiosity of the Week. Stanley from Ohio thought that maybe it was a model of a duck, which is a good guess. You can see there's some similarities, but as we learned, the object isn't a bird. Ellen from Wales thought maybe it was a child's puppet from Indonesia. And then Huka from Hawaii guessed that it was a kind of a mask. So all 3 were really great guesses. Our student from Hawaii was the closest. And so the object was a fire dancer mask from Papua New Guinea. Very, very cool. let's take a look at this week's curiosity and let's get those guesses coming in.
Curiosity of the week are these two objects here. Can you guess what these are? They're quite hard. If you can work out what they are, can you decide which animal this one comes from and which animal this one comes from? Tune in next week to find out.
All right, so another challenging curiosity of the week. You can send in your answers to classroom@darwin200.com, and let's see who can guess this week's curiosity of the week. Remember that you have 1 week left to get your answers in for the experiment, the pitfall trap. We hope we see some amazing photos coming in from students. We'd love to see what kind of invertebrates you caught in your pitfall traps. And then, of course, we'd love to see some clips of the snail experiment, watching the snail and learning a little bit about how it moves. If you visit the website, darwin200.com, you can find the video if you want to watch it again. You can find a PDF with instructions, and then, of course, where to send it in to classroom@darwin200.com. Well, that is going to wrap us up for this week's World's Most Exciting Classroom. We should just remind everybody that we'll be doing it all again next week on Thursday at 9 a.m. Eastern, 2 p.m. UK time. And this time we will have arrived. We will be in Fernando de Noronha, and we will have some conservationists join us live. Hopefully we'll be in a really cool location in the field. We'll have a new experiment, curiosity of the week. It'll be another jam-packed event as always. The last thing we're going to do for today, we have to take a moment and we have to thank our sponsors. Without our sponsors, this expedition wouldn't be possible. We wouldn't be able to do the world's most exciting classroom. So a huge shout out and a big thank you to all of our partners and all of our sponsors.